All right, now that we know how to work with equations that involve rational expressions, let's solve some formulas for a variable within the formula. Let's start with this one. I out is equal to a v n over RL plus RF. Now, in many formulas, the variables have subscripts such as RL and RF is to distinguish between this R and this R. Whenever you write a formula or work with a formula, make sure that you write down the variables exactly as they appear. Don't change small letters to capital letters and don't change capital letters to small letters. So what we want to do in this formula is we want to solve for Vn. Alright, so let's solve for Vn. Well, this formula has a rational expression, and most of the time when we are working with an equation that has denominators, we choose to get rid of the denominators. So that's what I'm going to do here. I'm going to get rid of the denominators by multiplying both sides by the denominator. So I'm going to multiply this side by RL plus RF, and I'm going to multiply this side by RL plus RF. Now, on the left-hand side, I just have RL plus RF times I out. And on the right-hand side, the RL plus RF cancel, and I end up with a Vn. Now, it is very simple to solve for Vn. I simply divide both sides by A, and I have my answer. Vn equals RL plus RF times I out over A. So there's my answer. All right, let's do another one. All right, so let's solve the formula FC equals 1 over 2 pi RS plus RL times C. All right, so I want to solve this formula for RL. All right, well, this formula has a denominator, and I could do as I've done before and multiply both sides by the denominator to get rid of it. Well, let's do that to start with. So I'm going to multiply the entire equation by this denominator, which is 2 pi RS plus RL C. And so I do the same thing over here. Now this time I'm just going to put the whole equation in brackets, and I know that I'm multiplying both sides by this. Anytime you do something to an equation, you have to do it to both sides so that you don't change the equality. All right, well, when I multiply this denominator by FC, then I just get all of those things multiplied together. 2 pi RS plus RL times C times FC. But on the right-hand side, the denominators cancel, and so I just get 1. Now I'm solving for RL, so what I'm going to do is divide all of these, both sides by all of these, except for the RS plus RL. They're in parentheses, they're like a group. I can't separate them right now unless I want to use my distributive property, and I don't want to do that. So I'm going to divide both sides by 2 pi C FC. All right, well, when I do that, on the left-hand side, the 2 pi's cancel, and the c's cancel, and the FC's cancel, and I end up with RS plus RL. On the right-hand side, I just end up with 1 over 2 pi C FC. Notice that because I eliminated the denominator, the entire denominator in the beginning, that I moved the 2 pi and the C. I didn't really have to do that. So we'll work the problem another way in a minute where we don't do that. All right? But now I'm just going to subtract RS from both sides. And I have RL equals 1 over 2 pi C FC minus RS. And I have solved the equation for RL. Well, let's do this another way. Same problem, but this time, so let's write the equation again. 1 over 2 pi RS plus RL times C. This time, I'm only going to move the RS plus the RL, the two terms in parentheses. So I'm going to multiply both sides of my equation by RS plus RL. Now I'm putting the entire equation in parentheses to show that I'm multiplying both sides by RS plus RL. All right, well, when I do that, I have RS plus RL times FC equals 1 over 2 pi. Now in this case, on the right-hand side, the RS plus RL cancel, and I just have 1 over 2 pi C. All right, well, here I have a choice. I can multiply through by my FC and then separate my terms, or I can go ahead and move the FC. I'm going to go ahead and move the FC, so I'm going to multiply by 1 over FC to move it. Now, normally I would divide by FC, but remember that anytime you have fractions in your equation and you want to divide, multiply by the reciprocal instead. It gives you a much nicer looking answer. So I have RS plus RL equals 1 over 2 pi C FC. Now, I'm just about where I was right here. In fact, I'm exactly where I was right there. So again, I will subtract RS from both sides. And when I do, then I'll have RL equals 1 over 2 pi C FC and then minus RS. All right, it does not matter what order this 2 pi C and FC are in. Remember, the commutative property says that the order when you're multiplying is really not important. All right, well, these equations had the variable we were solving for only once. But we're going to use an equation that has the variable that we would like to solve for in it more than once. All right, so here's our equation. P plus 1/2 rho v squared. Now, this is the Greek letter rho. It looks kind of like a small p, but it's really the Greek letter rho. Plus rho gy equals k. We're going to solve this equation for rho. Notice how it appears twice in the equation. Now, the first thing I'm going to do, though, is multiply the whole equation by 2 so that I can get rid of this 1/2. That's a 2 in the denominator, and I would like to get rid of it in the beginning. So I'm going to multiply the entire equation by 2. And when I multiply 2 times p, I get 2p. But when I multiply 2 times 1/2, the 2's cancel, and I just get rho v squared. And then I multiply 2 times rho gy, and I get plus 2 rho gy, and then equals, and then 2 times k. Don't forget that you're multiplying 2 times every term. All right, well, now I want to solve for rho. When you're solving for a variable that appears more than once in the equation, you want to get the terms that have that variable together. Get those terms together on one side and all of the other terms on the other side of your equal sign. So these two terms have rho in them. They're together, but I need to move the 2p. And to move terms, we add and subtract. So I'm going to subtract 2p from both sides. And when I do, then I have rho v squared plus 2 rho gy equals 2k minus 2p. All right, now once I get my terms with my variable together on one side, then I can factor my variable out of those terms. So I'm going to factor the rho out, and I have v squared plus 2gy equals 2k minus 2p. All right, so all I have to do now is divide by the v squared plus 2gy on both sides. It goes away over here, and so I have rho equals 2k minus 2p over v squared plus 2gy. All right, now, I didn't have to multiply the equation by 2 to begin with. I could have changed the 1/2 to 0.5. That would have been fine. Sometimes there are different ways to work the equation, and you and someone else may get a different expression, but they're exactly the same. They don't look the same, but they're both correct. So keep that in mind when you're solving these formulas for a variable in the formula. There's not just one right answer. All right, last formula, VTH equals R2 over R1 plus R2 times VDD. All right, in this formula we're going to solve for R2. Notice that R2 appears twice in the formula. Okay, first thing I'm going to do, multiply both sides by my denominator. I want to get rid of the denominator. So we multiply this side by R1 plus R2, and we multiply this side by R1 plus R2. All right, well, on the right-hand side, R1 plus R2 cancel. So I now have R1 plus R2 times VTH on the left equals R2 VDD on the right. Okay, I need to get my R2 terms together. Now, I have a choice here. I could divide both sides by VTH and then subtract the R1, or I could go ahead and use my distributive property and get rid of my parentheses. I'm going to use my distributive property this time. There's not one right way to do this. All right, this is just my choice, so I'm going to multiply R1 VTH plus R2 VTH equals R2 VDD. Now, I have three separate terms, and two of them have R2 in them, so I want those two terms together on one side of the equal sign. So I'll subtract R2 VTH from both sides. And then on the left, I'll have R1 VTH equals, and then on the right, we'll have R2 VDD minus R2 VTH. All right, well, now I can factor my R2 out. So on the left, I have R1 VTH equals R2 times VDD minus VTH. Once I've factored my variable out, remember, this is something you do when the variable appears more than once. You factor it out. Once I've factored it out, I just divide by whatever's in parentheses so that I can move it to the other side. All right, and so now we have solved for R2. So R2 equals R1 VTH over VDD minus VTH. And there's my answer. When you're solving these formulas for a variable, don't get too frustrated. It takes a while. There are no specific rules. You may work one problem one way and another problem another way. It all depends on what you see that you can do and what you're solving for.